Hello, I'm Laura.
And I'm Duzzer. Hi, and welcome to Duzzer's Wonder Math. Look, the universe of math is in front of you. Join us to explore Duzzer's Wonder Math that brings the universe of math into your grasp and empowers you to move forward. Together, we'll review what you already know and gradually move from the known to the unknown. We will use a new approach that's less formal, more visual, and guarantees success. Okay, let's dive into the universe of equations and inequalities.
Sharpen your pencil and open your notebook. You are going to overcome your fear of this universe.
Our first challenge is equations and inequalities. Here they are. Take a look. Have you met these guys before? Are they your enemies or your friends? They'll be your friends after this. Don't be afraid. We'll move at your pace from the simplest to more complicated. Good luck.
The real number line is our start. This is a short review. The graphical representation of numbers is called the number line. 0 is the origin. From origin, if you are moving to the right, as you see, positive numbers are getting larger and larger. If you are moving to the left, negative numbers are getting smaller and smaller.
I see that positive numbers are always greater than negative numbers.
Good observation.
And furthermore, I also see that numbers grow from the left to the right.
It's true. To compare numbers, we use these three symbols. If we have two numbers, -2 and -2, what symbol should we use? -2 is equal to -2, so we are going to use symbol equal. Now we are going to think about symbols of inequalities. For instance, if we have two numbers, 2 and 3, what symbol should we use? It's obvious that 3 is greater than 2, or we can say that 2 is smaller than 3.
But Laura, how do you know the direction of the symbol of inequality?
Oh, I have my helper. Our bird is always greater than an insect. So 3 is the bird and 2 is an insect. The beak is a good tester.
Can this bird make a decision which number is greater?
Oh no, bird can only reflect my decision. Let's try two negative numbers, -3 and -2. Looking into number line, we see that -2 is greater than -3. So we have two options. Which one to use? Let's start the first one. And our expert is going to check. Our expert rejected the first symbol, and the second one worked very well. Now we are sure that our symbol is correct. It shows that -2 is greater than -3, or we can say -3 is less than -2.
I'm sorry, but it's not very clear to me how to work out problems similar to this one.
Okay, let's use a more visual approach for the next example. If we have two numbers, 0 and -5, which symbol to use? On the real number line, we have to highlight first number, which is 0, and then second number, which is negative 5. As you remember, all number growth from the left to the right. So which number is larger?
0. And 0 is my bird. 0 is greater than negative 5. I got it. And how about you, my friend? Let's practice a few examples to feel more comfortable. Watch me as I am solving the problem. Think about what I'm doing and why I'm doing it. Now, solve the same problem using your thoughts and observations. Good. It's my turn. Watch me. Now, you do it using your thoughts and observations. Okay, now, this problem is your challenge. You're on your own. Check your answer. All right. Thinking and observation are the keys to our success. We are ready to move forward. Laura, working with fractions has always been difficult for us. Please help us. Say we have two fractions. How can I tell which one is larger or smaller, and how to show the symbol of inequality?
Comparing fractions is simple when the denominators are the same. Let's look at this example. First fraction is 2 over 5 and second is 4 over 5. To answer your question about which fraction is larger, you just need to look at real number line. For convenience, we divided each unit into 5 parts since the denominator is 5, and show scale in fraction 1 over 5, 2 over 5, 3 over 5, 4 over 5, and so on. Now we have to highlight the first numerator, which is 2, and then second numerator, which is 4. And you remember that number grow from the left to the right. Can you decide which numerator is larger?
Yes, it's obvious it's 4.
The fraction with the larger numerator represents the larger fraction, and it's our bird. Can you make a sketch?
Yes. So 4 over 5 is greater than 2 over 5, or we can say that 2 over 5 is smaller than 4 over 5. I got it.
Now you have to take similar actions in order to compare negative fractions, negative 2 over 5 and negative 4 over 5.
Okay, highlighting the first numerator, negative 2, and then the second, negative 4, we remember that numbers grow from the left to the right.
So which numerator is larger?
Negative 2. And negative 2 over 5 is my bird because negative 2 over 5 is greater than negative 4 over 5. I got it. And how about you, my friend? Let's practice a few more examples to feel comfortable. Watch me as I am solving the problem. Think about what I am doing and why I'm doing it. Now, solves problem 6a using your thoughts and observations. And now 6b. Good. Problem 7 is your challenge. You're on your own. And now problem 8. Check your answer for problem 7 and 8. Thinking and observation are the keys to our success. It wasn't difficult.
You are right. It was easy because we had the same denominators. We practically compared the numerators only.
But if we need to compare two fractions when the denominators are different, like 2 over 3 and 3 over 4, what should we do?
First, can we do something in order to have these two fractions with the same denominator?
Let me think. Oh, yeah! We can use the lowest common denominator between the fractions.
Great idea. Let's start by finding the lowest common denominator between the fractions.
Okay, 3 times 4 is 12. Then, if we multiply each fraction by 1 using 4 over 4 and 3 over 3, as a result, we have two fractions with the same denominator, 12. So now we can repeat the steps which we used before.
Yeah. For convenience, we divided each one unit into 6 parts and show a scale in fractions, 2 over 12, 4 over 12, and so on. Now, can you decide which numerator is larger?
Oh, it's obvious. 9 is greater than 8. The fraction with the larger numerator represents the larger fraction, and it is our bird. So 9 over 12 is greater than 8 over 12, and 2 over 3 is smaller than 3 over 4. I got it.
Now you have to take similar actions in order to compare negative fractions. Negative 2 over 3 and negative 3 over 4.
Okay, the least common denominator is 3 times 4 equals 12. Multiplying each fraction by 1 using 4 over 4 and 3 over 3, as a result, we have two fractions with the same denominator, 12. Now, highlighting the first numerator, negative 8, and then the second, negative 9, remembering that all numbers grow from the left to the right, so negative 8 is greater than negative 9, and negative 8 over 12 is my bird. Negative 8 over 12 is greater than negative 9 over 12. And our final answer is negative 2 over 3 is greater than negative 3 over 4. I think I got it. Problems 11 and 12 are yours to solve, my friend. Now, check your answer for those problems. Good.
We'll continue to work on symbols. We use these symbols to compare numbers, and now we are going to expand their applications. These symbols can be used to compare different types of expressions. Suppose we have two expressions, and one of them, or both of them, with a variable. The first expression is x plus 2, or x and positive 2, and the second expression is 3. If for some reason they are equal, then we can call them an equation. If for some reason one of them, the left one, is smaller than the right one, we can use the symbol of inequality, and it will be an inequality.
But how to read this?
We can use our helper. Our bird is always greater than an insect.
I remember that. So x and positive 2 or x plus 2 is less than 3.
Yep.
What would happen if the right expression is smaller than the left one?
Okay, then we will have another inequality. And our expert help us to read it.
Yeah, x and positive 2 or x plus 2 is greater than 3.
Sure. Let's talk more about symbols of inequalities. Here is a statement: 2 is less than 3. I copy this inequality and twirl it around. Now we have an equivalent statement: 3 is greater than 2. For numbers, it's clear that these two statements are equivalent. But to reinforce this conclusion, we can use our expert. As you see, the top picture shows that 3 is a bird, and the bottom picture shows that 3 is a bird. So both statements are equivalent.
Yes, they show that 3 is greater than 2. Would twirling work for inequalities with negative numbers?
Let's see. Okay, here is negative 3 is less than negative 2. Twirling it around, we have slightly different notation of the same statement.
Our experts show that negative 2 is greater than negative 3. Cool! I like this twirling. It's clear that twirling works for statements with the equal sign.
Twirling can be very useful if one expression is a variable. Here are some examples of how to use twirling to get equivalent statement. 2 equal x or x equal 2. These statements are self-evident. Next example. 2 is less than x or x is greater than 2.
What does our expert tell us?
That these two statements are equivalent. Both say that x is greater than 2. One more example. Negative 3 is greater than x, or x is less than negative 3.
Our expert shows that these two statements are equivalent. Both say that x is less than negative 3.
The idea of twirling will help us later on.
And now, my friend, you practice twirling on problem 13, parts A, B, and C. Take your time, use your thoughts and observations. When you're ready, check your answers. And here's problem 14, parts A, B, and C. Again, work out the problems and check your answers. If you're ready, here are the solutions. If you solve the workshop problems correctly, then we can move forward. If you didn't, don't worry. Please go back over the material and remember that your success depends on thinking, observation, and learning from mistakes.
We will continue to work on symbols. Working with real numbers, we often use two more symbols and words: negative infinity and positive infinity. If you are moving from the origin to the right, the numbers are getting greater, greater, and greater, and we can say that we are moving towards positive infinity. If we are moving to the left, numbers are getting smaller and smaller and smaller, and we can say that we are moving towards negative infinity.
Once again, all numbers grow from the left to the right. I developed a visual image of positive and negative infinity. Looking into the universe helps us to extend our understanding of negative and positive infinity. If we are moving from the origin, the numbers are getting greater, greater, and greater, and we can say we are moving toward positive infinity. If we are moving into the opposite direction, the numbers are getting smaller and smaller, and we can say we are moving toward negative infinity. All real numbers grow from the negative infinity to the positive infinity. Nobody knows where positive and negative infinity are. It's beyond our imagination. It's the idea of something that has no end. We use those two symbols as the smallest possible negative numbers and the largest possible positive numbers that we never can reach. It's the first step toward the concept of the universe, which is by itself very complicated. This session is over, and we are ready to move to the next one. Solutions of linear equations and inequalities in one variable and types of notation. See you soon, my friend. Bye-bye.